Hello and welcome back to a new video here on the Lötwig Fusel channel. Today we're gonna start with the video series for the commercial grade C++. Today we're just going to set up a bit of our repository, talk a bit about what the project is going to be and what hardware we're going to use, what I plan to do, and if you really need to buy stuff for that or if you can just get away with the PC, which is of course the case. And I'm just going to introduce everything, how we're gonna progress with the software and the project. Now, the first thing that we want to do is we want to create ourselves a repository for the project. So I'm going to use a template here. It's moxpp. I already introduced that it will be moxpp. So I will create a new repository with moxpp. So template mox byte moxpp. You can do this as well. It's a public template. And then what I am going to do is I will call this one CGPP, which is commercial grade ++, or actually it should be CGCPP. It's just the repository name for the project. I don't want to name it yet. I have not a bit of an idea if we're really going to go get something nice going. I just want to have a bit of a basic name so that we can start. We don't need a description, so let's just create this repository. It will instance it, and there you go, it's done. And it will also, or it should also start the continuous integration for this project. There you go, you can see continuous integration is starting, which is nice because that's what we want. And what we now want to do is we now want to get the repository to our computer. So we're going to copy the Git URL, and I think I will maybe have a bit of a problems with the Git URL because I think I haven't set up Git yet, but this will be easy. So let's quickly git clone inside of this directory. Now the problem with Git is that I had to completely reinstall my Windows and everything is gone, and I think I have not yet set up Git, but for this video today it should not be a problem because we don't need to push the code back. I can do this after the video, after I started with this. Okay, so let's now open this up with Visual Studio Code. Let's zoom a bit in so that it's better for the video. Okay, so now we are inside of Visual Studio Code and we have the repository here. Now the README is going to contain a checklist what we should do. Since this is my project template, I know what we want to do, but if you are new to moxpp, you can take a look at this checklist and see what you need to do to get this project up and running. I might come back to that one after we started, but let's first start by configuring everything like we want to. Now the first thing that we want to do is we want to go to our Conan file and check that our project is configured the right way. Now currently you can see we have the gtest. That's okay. I want to do a bit of a cleanup in here, so I will call this CGCPP recipe. It doesn't really matter the name, but it's good to have it named in the correct way. Then I'm going to label this section test. So that's all that we need for the unit testing. And then I will label this section, I will label app. So everything that we need for our commercial grade app. Well, actually, we're not going to build an app. We're going to build a service. Well, actually, yeah, it's kind of like both. It's a bit different. You're gonna see how this will go because I will also show you how to integrate this with the real world. And that's something that's completely new. We're going to have an I/O card associated with that project that is going to switch actual digital outputs in the real world. So you could integrate this into some machine that you build. So the machine is being run by an industrial IPC, a computer. You could, for example, take a Raspberry Pi. Even though I think my moxpp recipe currently does not support a Raspberry Pi, but there are also small x64 PCs and x68 PCs that are supported. So 64-bit I only support. Okay, so I want to label this general because I'm going to have a few general dependencies, and that's what I want to go to a bit now. So SPDlog is something that I want to use. I just want to check if there's maybe a newer version. So there's 1.14.1, and you can see that we are still using an old one. So I'm going to upgrade SPDlog to the latest version. And I'm also going to explicitly recommend FMT because I'm explicitly going to use FMT for this project. Okay, so now we have FMT and SPDlog in there. Now our project will consist out of multiple parts. We will have a web server. And for now, we will have a machine interface. So an interface to connect to the machine. So all of these require something. And yeah, we want to start with these later. Now there's some more general dependencies that I want to have. I want to have boost, because boost is going to make our life a lot easier. We're going to, I think, I'm not sure if I really want to have boost CPP, but I want to quickly check if there is a certain library instead of boost, because I don't know boost completely. No, I don't think I want to go to the getting started. I want to see the libraries list. But I think there is, isn't there a threads library? Let's see, fiber, userland threads. I think there was a thread library that has a bit more options in here for handling threads, and this is why I want to have boost inside. So let's get boost. So as boost, I would say, is like a general requirement that we have. So we have boost inside, and what I do want to have is I want to set up a option for boost. So in this case, it's not going to be spdlog, it will be boost without fiber, and we're going to set this to false because there's some issue with the fiber library. We don't really need it yet, but I have already a pre-compiled version of that on my machine, and I don't want to recompile it, so I personally always explicitly set this to be, yeah, to probably support the fibers. I'm not sure if the option that I've selected is right. It's a bit of a pity that you cannot see the options in the GitHub Center. But it's just like that. So it's fiber, and they have always the option without. This is just how they roll and how they implement that with Conan. So without fiber, false is the right option. So now we have a bit of like common libraries inside. So we have some logging in there, we have boost in there, and we have FMT in there. Now we can go to the more specialized modules. We're going to need a web server module. So I like to use CPP HTTP lib, I think it's called. Or is it just called HTTP lib? How is it called? CPP-HTTP lib. I already showed this in a video a few years ago that was also quite yeah, liked on the channel. This is just a very simple library that allows you to yeah, serve web pages. Now we need to pimp this web pages library a bit. We need OpenSSL to have SSL support. So I just take the normal OpenSSL, the latest version here, and I'm also requiring these. So OpenSSL is needed. Then what we need is we need some template engine. Template. We can just look for template, and I want to have this one. I think it's the Pantor Injure template engine, which allows you to yeah, use like these J-Injure templates yeah, that were like used for like Python. Allows you to use these in C++. Okay, so let's require this as well. That's a typo. Let's do it like this. I like to always order them so that they look nice, because like there's no really way to find a proper order there. Okay, so let's continue now with the libraries that we need for the machine interface, because that's the web server. We have the web server itself, we have OpenSSL, we have a way to generate the web pages. That's everything that we need. Now we can go to the machine interface. So what do we need for a machine interface? We need Modbus. Modbus is a really simple bus protocol. If you look for it, Modbus, in general, it's a bus protocol. If you take a look at that, Modbus, you can connect it to a PLC, for example, like this Siemens PLC, input-output modules, sensors, meters, and yeah, basically it's an Ethernet-based protocol. You have a switch in between, and then you can have like yeah, like some master, some PLC master. In our case, the master will be the computer, and you can control these devices. Actually, with Modbus, you can go quite far. You can even control frequency inverters with Modbus, which is like really, really cool. Modbus has two different types. It is either per network or it's per RS485, I think, per RS485 bus, I think, with like termination resistors and everything. And we're going to use, of course, the network-based protocol. I think you can actually have like some device in between. I think you can have a Modbus RTU TCP gateway in between. which allows you to connect the network on the one side and the classical bus at the secondary side. And the way Modbus is built, it should work without any big configuration to just talk via the TCP protocol to the RTU devices, which is like really, really cool. Like if you know how Modbus works and you integrate it into your software, it's really, really nice. And of course, there's a library for that. There's libmodbus. I'm personally not too big of a fan with that, I think, because you have this disclosed source condition in the license. So if I do it for a commercial project, I'm not going to use libmodbus. I know how libmodbus work, and for open source projects and this tutorial, just for the ease of use, it's good to use. But in the end, if you want to really make a commercial product, I would not use libmodbus. The thing is, Modbus packet structure, if you want to take a look on how the how Modbus internally works, Modbus is a really, really simple protocol. You see, like here, in a Modbus message, it has like the slave ID, a function code, some data, and some CRC, but only the CRC if you are on RTU and not on the TCP-based protocol, because TCP already includes that. Now, it's quite easy. You just need to have this ID, the function code, and the data, and then it works just easy. Normally, I think the slave ID is not used on TCP. It's only an RTU thing, because on TCP you address it by the IP address. So you always go like to the slave ID of 0. But I think if you have a gateway, you use IP address to address the gateway, and then use the slave ID to then kind of like address the slave number in the old RTU RS.45 network. So if you want to implement Modbus by yourself, it's easy. I think I even have made a live stream that should be archived where I implemented Modbus, because Modbus is just a very, very simple and easy protocol. But for our purposes, libmodbus will be enough. We can just shove it in there and we can call it a day. There's one thing that I forgot. Of course, we need some way to configure our software, and we also need a way to configure our templates. So we need a JSON library, and it's quite hard to find Nloman if you just look for JSON. There it is, Nloman JSON. That's the JSON library that I want to use. So let's also in general like require Nloman JSON. So basically what we have now is we have some formatting library to format text. We have a logging library. We have Boost for several utilities. We have Nloman JSON for JSON configuration. We have a web stack included in here, and we have a stack included for libmodbus, and we have a library for unit tests. In this case is gtest. All right, well, we can remove the pass here because we implemented the configure function to configure the libraries as well. Now that's everything we need. Now we can start like modifying the project. Now how do we do that? We configure that by going to mox.lua. This is the main configuration file for the project, and we're going to rename this in CGCPP. So CGCPP is commercial grade C++. That's the product name. I want to have multiple configurations. Or do we really need multiple? I don't think we need multiple. We can get away with just debug and release. Normally, I also add the... oops, no, caps lock is on. Okay. Normally, I go for a development configuration because I think it's good practice to do. Maybe we should do it. Development. Let's add a development configuration as well. Basically, development configuration means like having all the debug support in it, but without the debugging symbols. So basically, development is not a debug configuration, but it still is like a logical debug configuration. I think every modern project should have these architectures, even if you might not need these. I think I should implement them in the template by default, but yeah. Now we need to have a bit of a project architecture. Currently you can see that we have a single project. Now normally this is okay. I'm personally not a fan of the single project architecture. I most of the time these days go for a flat architecture or a hierarchical one if the project is much more complex, but I think flat is the way to go these days. Now you can see that we have this macro prefix. We of course want to have this to moxpp. I want to have this to cgcpp _. So we're just going to paste it in like that. That's everything that we need inside this file. We can call it a day. That's okay. Now what we need to modify is the layout of our source directory. So I'm going to create a new folder and call this one cgcpp because this is the name of our project. I'm going to move all the files in here. This is why I like to have it as a flat architecture, so that I at least have the option to later add new libraries or utility projects in there, and I also have a bit of a structure in there. Of course, I could bring in the structure manually, but I think this is how you should do it. Okay, so now let's change a bit how this one works. We know that will be the same, console will be the same. Now currently for unit tests, this layout is not so good. Maybe we should disable unit tests in general, but I don't want to have it. I just want to have it as a dummy unit test project because I think normally you should do it. Or maybe maybe we should still have unit tests in mind. Let's make this a shared library and have unit tests in mind. Let's quickly copy and paste the folder here, and let's call this one CGCP host, which is going to be the host application, and this will be the library that runs everything. So we don't need this one. We can call this one dummy.cpp for now and just leave it empty. Then this is a shared library, and since it's a shared library and we need it for unit testing, we can configure this as a test requirement. Everything else we don't need that. That will be set it up automatically. And of course we're going to change the name, so CGCpp, or I want to maybe call this one libcgcpp, so that we're gonna have a bit of a naming convention for the library. Okay, so we're gonna call this one core lib with all the codes, so that we can reference the code in the unit testing library. And then in the host application, I do just want to call this CGCpp, so CGCpp like this, so that you can then like run the application. Now you can see that there's a bit of a difference between the name and everything. Maybe that's not so cool. Let's maybe call this one lib. I don't know. I don't like it. I think if I include this, I should include CGCpp and then have the host like isolated. We can't just keep the folders like that. It doesn't matter how the final executable is named. So I think it's okay. So now what we need to do is we need to set up the links to the project. So we're going to take this links body. And what we're going to link is we're going to link to... do I have something? Oh, okay, my Windows V is not turned on. Okay, so now it's turned on. libcgcpp, so yeah, we're just going to link like this, and then we're going to call this one host application for running the code. So that's everything, and yeah, now we have a library and we have a host application, which makes the unit testing and things like that quite more simpler. And yeah, that's more or less everything that we need to do. Let's open up a new terminal and let's run mocks init to initialize the project, which should generate everything. So let's see that we don't get any issues here. Okay, it seems good. It's now going to compile and build everything. You can see that I have a few new build requirements for libmodbus, OpenSSL, and SPDlog, because it seems like I've taken a bit more modern version. Is it really that I have a newer version of OpenSSL now? That's amazing, because OpenSSL does take quite a while to build. So I think I will pause the recording now so that this can build, and then yeah, we're going to see when it's finished again. Okay, so see you in a sec. Okay, so it finished generating everything. You can see it finalized, install finished successfully, building configurations, and a Visual Studio solution has been created. So if I start this one, I just want to start a solution here, I can just enter the name and it will open the Visual Studio instance with that solution. That's quite easy and handy. Yeah, it will load the solution in and we can check if everything worked. Okay, I can already see 3 projects, which is really cool. CGCpp, so this is the library. No, this is it's not a library because the library is here. The library is lib. There is the library and there is the CGCpp CPP executable. You can see that we have a hello world with SPDlog like this. And yeah, we have debug, development, and release. So just make a debug build here quickly. You can see that the library is built. The library is generated as DLL. That's not good. Why is the library a DLL? It should not. Did I make it as a shared library? I made it. Static. Static is what I wanted. If you regenerate this, you can do mocks init skip Conan. If you do that, it will skip Conan. It's okay to skip Conan if you're just changing something in pre-make, then it's okay to skip Conan, and I think now it should do. Yeah, now the library has been generated. And there you go. Hello world. We get a hello world in the console from SPDlog, which is exactly what we want. Yeah, now basically our project works. That's everything that we need. Now, of course, normally what you need to do is you need to adjust the building.md to make sure it's in line. Building should in general be fine without changing anything. And you should also change the readme, of course, normally, but I will, maybe we could quickly go over the readme. Check that it works. We check that, not on Linux. We change that, read and understand that, choose the project architecture. We did that. Add and modify the build scripts to the architecture. Okay, yeah, actually, basically, I know my thing. We can just delete that. We can just delete that and say commercial grade C++ tutorial repo. Just as simple as that. I just want to start with something really quick and dirty to get started. And yeah, that's more or less everything that we need to do for today. I want to show you a few more things before I leave you today. First of all, I want to show you the I/O system that I will be using in order to interface with the real world via Modbus. I'm using the I/O system von Weidmüller. I just happen to have one of these systems here. That's the only reason that I would use them. I'm normally a diehard Siemens fanboy when it comes to industrial automation. Like Siemens is for the buttons and the PLCs, and the I/O systems is normally what I would go for. However, I happen to have one set of the Weidmüller here, and it's also a really good module. It has actually some benefits that make some things better than with Siemens, but with Siemens it's a bit different. If I have a Siemens PLC, I buy everything from Siemens. If I don't have a Siemens PLC, and in this case we don't have any PLC because it's all controlled via our application, and yeah, then I could also see myself regularly using the Weidmüller system. It's a quite nice system. You have a modular approach. If you're not if you don't know automation technologies, it's all modular and it's all integrated. So here you have these I/O modules. So you select the I/O module that you need. If you take a look at the product catalog, you have like input modules, output modules, mixed signals, so input and output modules, pulse width modulation and stepper motor modules, analog input modules, analog temperature modules, and potentiometer modules, strain gauge module, whatever, I don't know that one, power measurement module, analog output modules, digital counter and communication modules, safe modules. So if you want to do safety, but you're not going to do safety with a C++ application in the background, just simple like that. You have power modules and potential distribution modules. So they are quite modular. For example, if you want to do it like PWM and you want to control, for example, let's say some LEDs. I'm not sure. Is there digital signals to PWM channels? Is there not some module that can do more PWM than 2? But yeah, I think this one is handling 2 PWM modules. Yeah, okay. 2 PWM, 2 amps. So you could control LEDs with that module if you want. If you take a look, you can also check how much they cost. Here the PWM module is like 300 euros. So we are definitely not in the cheap area. But yeah, you can do a lot with these systems. It all works via a bus system and you can just control the application. What I'm using is this Modbus TCP coupler. I'm also using the 16DI input card, and I'm also using the 60DO output card. I think the price tag of each of these modules is like 100 euros, but if you don't want to spend these, it's not a problem. You can still follow the tutorial without paying for these. For example, here, yeah, you can see it's like 100 euros is the module. If you buy them new, they might become even, you can even get this one cheaper for 48 euros. So yeah, you can get these for quite some nice price tags. If you don't want to buy them, Modbus Slave Simulator. There is a Modbus Slave Simulator that you can download here. I'm not sure if this is the one that wants you to buy them, but there is a free one. ModSim, it's called. This is a simulator application for Modbus. So if you don't want to buy like physical hardware, you can get one of these simulator applications running, or just simply implement yourself another software. You can actually even see that there is a script option in it. You can write some JavaScript to to kind of like respond to that. So you can write yourself a script to simulate it if you don't want to have real hardware, and you can just download this one as a exe for free. AMD 64. What the hell? Qt5 and Qt6. I don't like Qt at all, but you're not going to get around that. Yeah, but in the end, you have a lot of simulators there available. You can also see that there are DXLave Modbus simulator. There are a lot of people that make software for Modbus that you can get away without having a physical I/O system behind, even if you don't plan on using that. For me, it's just like to make this tutorial series a bit more interesting. Now in the end, how it's going to look like, for me, it's going to look like that. This is the Weidmuller product configurator. And I've just placed the modules in here so you can see how it looks. You have this head module, which we're going to connect to the computer via Ethernet. You have some power supply plus and minus here. And then you have the input and output modules. And yeah, this is what I'm going to use to show you a bit how you can interface with some real world hardware in here. Okay, so now everything is set up and ready to be used. But that's it for today's video. In the next video, we're going to start implementing the features. So see you in the next one. Make sure to like and subscribe and have a nice day. Bye.